So my keys to the future of 3D printing for production are broken down into basically four main categories. So design is a critical aspect of where we're heading with production. And there's been a lot of advancements in this space as well. The organic shapes and the designs that designers are doing today, nothing's square, nothing's flat. Everything is contours and stylistic shapes that are very difficult to manufacture in some spaces. When you get these geometries, where's the parting line? How can I make this? And designers are limited to how they manufacture a product based on the manufacturing process. So that's a huge benefit when it comes to additive, because we don't really have a whole lot of design limitations on product to manufacture. We don't care about nominal wall thickness. We don't get sink marks. We don't get knit lines. One thing that any designer will tell you that they hate to do at the end of a process is add draft to a product. It's the worst step of all. And nobody really wants to design with draft, but the reason you do is so that you can manufacture it. So we can start thinking about being able to design things without some of the limitations of how it's going to be manufactured. That's going to be great, which pulls us into designing for additive manufacturing, Dfam, a buzzword that we've all heard, but it's very critical that we start thinking about Dfam and truly designing for the technology and for the process. So when we talk about Dfam and designing for additive, there's three main categories that come up. So mass customization falls great into the additive space because we can throw multiple parts in, just like we saw with the Smiles Direct. We can do unique sneakers for every person's footprint. Impossible geometries, another one. There's no other way to make these parts. Additive's it. And with these impossible geometries, it's not put out there to just say, hey, let's see what we can make that's so difficult and complicated to create. It's, hey, what has given us more advantages? What's improving performance? And what does this do for us as we're developing products? What does this offer us? So it offers some really great things in certain cases. And then part consolidation, another space where it's huge when we start talking about inventory and supply chain and assembly, total cost of ownership. Where do all these parts live that have to be put together when they come in? So part consolidation is another big aspect of advancing things into additive for production. There's different design tools out there. So generative design exploration technology generates multiple real world products based on manufacturing constraints. Because number one, these designs are such organic shapes and designs that it would be very difficult, I think, for a design engineer to come up with such a structure like this. And just to show more of this part consolidation type of study, this was done by GM. And they took one of these brackets in the back and decided, hey, what if we can morph this into one part so we can reduce part count? And can we make something that is done with additive that will reduce the amount of assembly, the amount of stock, the amount of inventory of multiple components? Engineers, they did 2 weeks of generative design analysis. They were able to take 8 components shown on the left, upper left, and consolidate down to one component, which resulted in a 40% lighter part and 20% stronger. So that's a pretty significant impact. So these are the type of parts that I think we're going to start seeing more of in the future. We're going to see more of these crazy lattice structures, but they're not just cool looking parts. A lot of these have performance benefits and customization and part consolidation. All of these things go into the design. And I think design has a huge part of advancing additive to the next level.